So thank you all for being here. Um, so our slides are Macy's Thanksgiving Day Parade. Did anybody see the parade this year? Because they thought it was going to be windy, the balloons were so down low, it was the weirdest thing. So people looking out of their apartments would have only seen the top of the balloons. They were like basically almost on the ground. So anyway, um, you have this talking about the best way to work the problem. And I felt like that I was a pretty good critical thinker when I started like coaching math team a long time ago. And then when I moved to, and we did like local competitions and did really well. And then I moved to Memphis, and our public school that I taught at was coached by a wonderful woman, Miss Halfacre, who retired. And so then AP Cal BC and math team came to me because I'd had experience with it before at my other school and felt like it had been successful. In that environment, though, we quite often would partner with a boys' school in town called MUS, which your mom would know about. Memphis University School actually looks like a university. I mean, it's like an inner city public school, and we would go quite often with this boys' school and compete. We would form a team together because our team was incredibly good, thanks to Miss Halfacre, and their team was incredibly good. And so we wanted to like put them together and have like a really strong Memphis team. But oh my goodness, their three coaches, Steve Gadboy, William Murphy, and Nancy Gates. I was just like, I felt like a peon in their presence. Like I just felt like algebra student in the presence of calculus, divas or whatever. And so I learned a whole lot more and had to like go, well, I can work that problem. And I was kind of cocky about it, and I could work the problem. But when I looked at how they worked the problem, I was like, that's how we're going to win and go not just to little Tennessee and Mississippi things. We're going to go to Harvard, MIT. We're going to go to Princeton. The kids are going to place. They're going to not only do well on the AMC, they're going to go to the next level, which is the AIME, which I don't know if Mary Mountain Girl's ever done, but it's pretty regular. And then I had a few students who would go on to even to the next level. And your brains are all the same. It's just like, I'm just saying all of that because I kind of started like, well, I can work the problem, okay? But it was interesting to watch their minds at work and when I still learned from them. They're unbelievable. So anyway, did anybody get C? 25? Okay, I'm going to talk about a couple of ways, and I want your input also. You may have like added them up, the fractions, 1/4, 1/8, 3/8, and 1/4, and gotten, if you add those up, you get 1 out of a possible, however many. Another way to do it, though, is to like actually count. Let me look at my notes of how I thought was the best way to work it. I saw 1/4 of the squares was covered. Like this one and this one gives me a square. This one gives me another, quote, square if it was shaped differently. And then I get 2 squares. So I had 4 out of a possible 16 squares. So I had 1/4 of the squares, or 25%. I thought that was a good way to do it. All right, other comments? Is that what y'all did if you got it right? Okay, if you did add up the fractions, you get 1/4, which is longer, by the way. Could y'all see this was an 1/8? Because it's a half of the 4th. And you always keep your eyes open for tricks. This is 3/8, and this is 1/4. Not the best way to work it, but if you thought about it, look for quick ways to get yourself out of these fractions, because people are going to be going quick and hitting a buzzer or whatever, and you want to be that person. Do y'all see that adds up to 1? Because I have 4/8 and 1/2, so I have 2 1/2, so I get 1. All right, now obviously it's not 100%. It's 1 out of a possible how many? Okay, because you have 4 objects. But that one, it was a little bit harder for me to even really see. I don't know. Once I added up my fractions, I honestly didn't know what to do with them. So, I mean, I was like, I have 1 out of, but if you combine all of those, it basically fills up one of the squares. Did anybody look at it that way? Okay. All right, so that's a great way to look at it, is if you just sort of took these pieces and then shove all into it would fill this one up because you have one entire square with all of those, okay? I love just the counting the things. You'll see things like that on AMC, which is good. All right, let me let you try number 2. Grace had an idea if we want. It's hard for me to say merchandise.
It's just a fun game.
Yeah, and so I'll probably, if it's okay with her, I might share it with y'all. But it may, if you want to think of some other things or think along those lines. But I know we're also, some of us are getting a mathletes one, and you know, I don't know if you want a math team shirt, but let's keep talking about it and see, or maybe a math team something else, math team sweatpants, socks, bandana.
What was your idea for merch? It just had like I found like a ton on the back and it was kind of funny.
What is it?
It was like there's no square root of -1 in team.
I like that. There's no I in team. That was really cute. Math team. That's really cute. I really liked it a lot. I forgot what it was. I thought it was awesome. And that's really true for us. Okay. Anybody have an answer they want to shout out? Grace, what'd you get?
I got C.
Got what?
C.
C? Okay, I got 3 also. Did anybody else get 3? And then some people are kind of like, what am I going to do? Okay. Grace, you want to share with us what you did?
Yeah, so I just like did it like for me the easiest thing was to like pretend there was 100 students.
Exactly. I did the same thing.
Because
Okay.
it was like percents and percents of out of
Yeah.
100. So I found the averages like on my calculator, and then I wrote out like since the percents are 10, 35, 30, and 25, and I kind of just like subtracted from both sides until I found the number in the middle.
Okay. All right. So if you had, I did that too, and I think that's great logic to do 100 students. Is that what you did? Okay. So you only know the percentages, and so 100 is a good thing to go for. Anyway, I was thinking about something else. How many students have we already used up here? 75. So how many people made 100? If we have 100 students, then there's 25 that made 100. All right, so 10 people made a 70, 35 got 80, 30 got 90, and 25 got 100. And so if I add up all their test scores, it's 8,700. And how would you find the average or the mean score? Divide by 100, and so that gives you 87, which you can use your calculator on the AMC, but you know, you could also have added those up if you had to. Another reason to pick 100. All right, so you knew the mean was 87. The way I found the median was this way. I know it's right in the middle. And so as I counted down to these, this is 40 students. Thank you. This is 45 students. And this is 55 students. So up to 45 students, and in halfway 50, okay? Up to 45 students, I would list my numbers would be 70s and 80s. And then after 45 students, people made 90s up until what number? Like, I don't know if I'm explaining this very well. All right, so this was 45, and then, sorry, I'm having a hard time saying that.
I think they do it the same way Grace does it, like just
cross it out.
Yeah.
And then there's 15.
And those are the rest of the students. So I knew the middle had to be at 90, but it was hard to explain what I was thinking. So go with what you were saying, Kennedy.
It's kind of weird to explain, but you like cross from the highest number and the lowest number. Like,
So am I going to cross it out like this?
so if you just write across, like
Oh,
across
70.
the screen, I just wrote 10, 35, 30, and 25 because those are the percentages. And then let's say you subtract 25 from both sides. So I would cross out 10, cross out 25, and cross out 35 and put like 15 over it. And then you know that if you subtract 15 from both sides, you'll still be in the 30% range, which was the people who scored 90.
Right. These people are right in the middle. Another way to look at it maybe is what I was doing. And I think I can explain mine a little bit better. I don't want to mess with what you did. I like it. Up to 45, we had 70s and 80s. And then the next 30 students made 90s. So I know that I'm in like the halfway zone right there with the 90s. Does that help at all?
Yeah.
Okay. Okay. So I knew I did it easier than whatever I was saying. But yeah, your logic at that point, you've got to find out some way to like move everything aside. Did anybody start multiplying 10% times 70, 30%? Because you know the rest of the percentage is 25%, right? Anybody notice that? If you actually just go 10% of 70 plus 35% of 80, you come out right with 87. And then I guess you could apply the same logic to find the median, but you want to find a quick way to find the median, so that's good. And I would definitely use 100 students. Yeah, the median again?
No, like
No.
the 10% of 7.
Oh, like, and not using it with 100 students, or using it with 100 students? Okay, let's do this.
It's basically the same thing because a percentage is just multiplied by 100. So like in an average, you divide by the number. But if you just start by multiplying them by the percent and then you don't divide by 100 at the end,
It
just
get the same thing.
Oh, okay.
Okay. Or like Cecilia, like I could have said, like in my pre-cal class, I might have 21 students, but these are going to be uncomfortable. Like 10% of 21 students. I got to pick a number that I can at least get real 10% off. So 100 is a quick choice. But Grace may have told you what you wanted to hear.
Yeah, because what I did them like if there were 100 students.
Good.
I just said that there were
Okay.
like 10 students who got 70.
Yeah.
But I just didn't understand what you meant by like find the percentage of 70. Like.
You mean what I was saying at the end?
Yeah.
If I did 10% of 70 and 35% made an 80 and 30% of my students 90, and then the rest had to be 25% made 100. If you actually do that, it comes up straight up with 87.
Okay.
Because
Same thing as dividing everything by 100, but you're just already converting.
right, exactly. It just happens to be the same thing. That one made me really uncomfortable to do it that way myself. I started out and got 87. I'm like, wow, I don't really know what's going on. So I went back and said, there's 100 students. Then I could logically think about it.
Okay.
Pick it's a good idea to pick a number. I like that. That's what we want, okay? All right, we are going to do number 3 together. All right, read it. And you think to yourself, well, okay, that's great. I've got a calculator. And so I'll just punch these in and take the square roots off. What's going to happen when you put these in? It's going to be too big. You're not going to be able to do it for calculator. Sophie, it's D. So Sophie, you want to explain it?
So I was thinking about it like every number that's a perfect square times another number that's a perfect square is a perfect square. So like for instance, like 9 times 4 is 36.
so the number, like, so anything, so, like, when you have the factorial, like 17 factorial times 17 factorial, that would all be, like, a perfect square.
Wait, which one?
Like, for instance, for Keith, for, like, 17 factorial times 17 factorial would all be a perfect square because you have 2 of each number. But then you need to get, like, a perfect square for the number afterwards since it's all, like, since they're all numbers afterwards. So then, 18 divided by 2 is 9, and that's a perfect square, so you're gonna end up.
Awesome. I can't mess with that at all. Okay. What Sophie, I'm going to say it in a different way, but that's maybe better than what I did. That's very intuitive of you. What Sophie's saying is if you have perfect squares that are multiplied together, your result's going to be a perfect square. So there's a lot of things to talk about here that are great for math team. Let me go on and take Alice's thoughts. Go ahead, Alice.
So I thought that I started with A and looked at 14. Well, any of them really. If you take 2 out of one of them, that means you're gonna have 1, 2 left. So, like, because if you was using
Do you want to write it up here? I don't know if I can write what you're saying.
so, so if it was like 14 factorial, you would then have like 3 times 4, blah, 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 all the way to 14. And then for 15, you'll have 2 all the way to 15. And since you can cancel every number between out, 14, 14, you have these 2 numbers left. So then this would work for everything else. So if you look at 15 and 16, you know you would have the same thing except 2 and 16 that are left over. And that would be 32, which is not a square root.
Wow,
You keep going to 2, 18, that's 36, and that's it.
Done. That's cool. I don't know if did y'all follow her mind just then? Okay, couple of no's. All right. So, this is something I did because I didn't see it really, honestly, as clearly. I don't think at first as Sophie and Alice did. Okay. By nature, what I did, just as a math team coach, is I knocked them down smaller. And I thought, what would happen? This is always just a good strategy. I'm not going to all take away anything that they said was great. But it's a good strategy if you're stuck to go, let's knock it down to small numbers and then we can blow it back up. Okay? So if I did some of this and looked at it, watch what happens. You'll discover what those 2 girls have already said. 3, 2, 1 times 2, 1 over 2. All right, do y'all see these are perfect squares? It's a lot like what Sophie was saying. Do y'all see that I have the 2 times 2 in there? And now what's left, she said, needs to be a perfect square. Do y'all see that? All right, so on this next one, we had 4, 3, 2, 1, 3, 2, 1 over 2. That would give me a perfect square. And in this case, it wasn't on my question, but you see that that is 4 divided by 2 is 2. So I know this would also not be a perfect square, but now I'm on my game and I understand what I'm looking for. By the time I get to, like, let's say C, 16 factorial times 17 factorial over 2. That would be 1 dot 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 to 16. The next one would be 1 dot 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 to 17 over 2. It's a lot like Alice's. These are going to cancel out. Not cancel out, but they're going to multiply together to be a perfect square. And is there a perfect square left behind? No. But if I go to D, this number is going to be 18, isn't it? And what's 18 divided by 2? Which is a perfect square. You get it? All right, so I love what both of those girls did. That was great. I just wanted to coach and say, sometimes it's good just to knock it down to something you can look at, and then you can get your feet on the ground and go forward. Great. All right, let's go to the next one. I'll let y'all work on that for a minute. There's a best, fast way to work this one. I talked about this one with Mr. Hill yesterday, so I may be giving you his thoughts more than mine. It looks like we're co-coaching, but he sits there and eats. He's not even listening to me. Mr. Hill's a jerk. I hate Mr. Hill. Don't
What's
listen to nothing. I was giving you credit for the next problem.
Oh, I deserve credit.
I am. Shut up.
What's the problem?
This one.
Yeah.
At the top.
Oh, you had that sorted out.
I know, but I can give you. I don't know. We started talking about it too soon for me to think if I had it sorted out.
Oh, okay.
I don't know what I would have done.
Well, the first two things that I tried were wrong, so.
The first two things he tried were wrong, but he got to try. Anybody have an answer for 4? Sophie, what'd you get, Sophia? C. Anybody else got 3 yet?
Yes, I'm checking.
Okay. There's a really quick way to work this. And you know, I would say that if you sat there and watched Mr. Hill and I looking at it together yesterday, I'm like, hey, what do you think about this problem? We tried a couple of things that didn't work, but you try them really fast and until you really see what's happening. But you may have tried the right thing right at first. Sophia, what'd you do?
I realized it was a 30, 60, 90 triangle.
Okay, I didn't even think about that myself at first. I ended up at that, I think. This is 6 and 2 root 3. Wow, this is going to be great.
And I just drew the third out.
Wait, hang on. So, did you do the Pythagorean theorem and get the third side or not yet at this point?
I did it, but it wasn't really important. I didn't do Pythagorean.
Okay.
It was just 2 root 3. I mean 4 root 3.
So, how did you figure it out? It was 30, 60, 90 just from your ratios of 30, 60, 90?
Yeah.
Okay. So, I'm trying to catch up with you right now. All right, so if this is your short side,
That's 30.
then your long side would be multiply it by square root of 3 over 2.
No, just times root 3.
I'm sorry, I don't do it that way. Let me think. What are your ratios? So the short side's a, 2a, and root 3a. So you have 2 root 3 times root 3, and so that gave you 6. So you're convinced it's 30, 60, 90 because you have a right triangle. All right, so then what'd you do? What are we looking for?
Well, I
How long
found the hypotenuse, but I realized it wasn't really important.
Don't need it. Uh-huh.
Yeah, so I just drew the third out. Oh, I put the numbers to the angle. I mean,
Okay, so this is 30, and this is 60. Is that what you mean?
yeah, and
Okay.
I drew the third altitude,
All right, so the third altitude's coming from there.
and it has to be perpendicular to that. So if you draw a right angle, you realize the smaller angle, you see a smaller triangle with the 60 and the 90, and so the smaller equal, so it's also 30. And so I just used the ratios again to find the altitude.
Okay. At first hand, I thought it was me some sort of geometric mean problem, but it didn't work out that way. I think I still had. Is that what you tried? Did it work?
I thought of it at first.
Yeah. I don't think we had the right values to make it work, because really the geometric mean is once we found the hypotenuse, Libby, I would have needed to know this side and this side to compare it with my altitude. I think there's too many unknowns there, but that was first instinct. Then she went to similar triangles, basically, I think, and ratios. Is that what you did, Sophia? Sort of. Talk me through the rest of it. You.
Oh no, so we figured out that the small triangle inside is also 30.
Oh, so you did your ratios again and had the altitude and the. Did you do eventually? Oh.
No,
Oh, so then that took you right to it.
yeah, so I just, the
Okay.
smaller side would be root 3, and then the altitude would be root 3 times root 3, which is 3.
Exactly. Okay, so then she's got another 30, 60, 90 triangle to do this with. So then she knew her hypotenuse was 2 root 3, and then she can move backwards and forwards to find the missing side. And you needed, I guess, this side right here. Is that right? Yeah, 2. Wait.
Yeah, it depends which triangle you use.
the number would be bigger, easier with the bigger one.
Yeah, because then you just have to.
Because in the short sides just happen that side.
Yeah.
Okay, so anyway, let me show you what Mr. Hill thought of. I thought it was really good. Let me see if I can remember. I thought it was really cool. He went straight to area. So if I do the area of the big one, this big one right here, the area of this big one right here, it's 1/2 base times height. And so the area of the big triangle is 6√3. And then we did the Pythagorean theorem. But you don't really need the Pythagorean theorem if you'd realize it was a 30, 60, 90 triangle. I don't think we realized that at first. I think it dawned on us later. But if you didn't realize it was a 30, 60, 90, probably some other people in the room did the Pythagorean theorem. And so you have 2√3 squared. If you knew it was a 30, 60, 90, once again, it would have been easier. Plus 6 squared equals c squared. So that gives you, what does that give you, 12 plus 36 equals c squared. So I get 48. So that gives me 4√3. So this is 4√3 right here. X is 4√3. And then I can find the area of the triangle again. Shouldn't I be able to do 1/2 base times height? The base I know now is 4√3, and I'm looking for the height. But it's just a different way to find the area of the same triangle. It's got to be 6√3. Y'all see that? So this gives me 2√3 times x equals 6√3. And so, what was c? Anyway, so you can see easily that x would be 3 to make that happen. So Mr. Hill thought of area. I honestly asked him too fast to even, I just like, what do you think about this problem before I really thought about it? And I don't know what I would have thought. I would like to know. I'd like to see it afresh. I would say let's really open our ears and minds to what Sophia said. I want to be on the lookout to do that kind of stuff to us a lot, to where it's something very common if you're a student enough to realize it. You know, like Sophie, like you said about the perfect square kind of thing. A lot of times it is going to be a 30, 60, 90. And I would tell you, even if you're not sure, in this case we can be sure. Even if you're not sure, I'd say if it gets you another point, run with it. There's some contests we'll do where sometimes there's a penalty for guessing that we'll worry about all of that in the contest that we sign up for. Okay? AMC has a penalty for guessing. If you even know what that means, and we'll talk about how to score that up another time. I'm going to go back to hers because I really, really like that. And the bigger triangle, once you know, she didn't even need the hypotenuse. So I over-talked this problem based on what she realized from the beginning, and that person's just done. Because if you realize that, did everybody catch all the 30, 60, 90s as Sophia was talking? Okay. So now this is the hypotenuse, and so the short side would have to be 3, because it's got to be half the hypotenuse, and you're just done. It's really nice to look at it on the screen, too. I think sometimes on my paper I don't see the things that I'd like to see when it's up on the screen. That's great. That's good. Okay, here's one thing I would say, though. You can't help it sometimes if you go in the wrong direction, like, we thought of geometric means at first. If it's not getting anywhere, abandon and go to something else. But it's good because it may make you think of some other things that you can do, okay? So techniques that we've talked about today, be on the lookout for things that you suspect might be happening. Double check it and see if it's right, because then you can go forward with it. Things like if you want to know if something's a perfect square, like Alice and Sophie did, you just start kind of shoving aside things you already know that are perfect squares, and if it's a multiplication, the one that's missing has got to be a perfect square. And also, if you have really big numbers, knock it down to something small. Or if you have percentages, make the count 100. There's all sorts of things that you can do that are really fast that you wouldn't learn in class, which is why you're here right now. All right, so number 5, I'll be interested to see how y'all do this one. Has anybody done 5 yet? Okay, yeah, I know y'all will. I know your little minds. I almost gave these to you one at a time on slips of paper. Hopefully you are smart enough to listen and work. I knew you would work ahead. So let's move on, okay? Some of y'all were not working ahead. Next time I'm giving to you on little slips of paper. What'd you get?
B.
B. All right, so anybody want to tell us what they did? All right, Grace, and then we'll compare. What'd you do?
Well, they
Probably
said,
something better than me.
they said that so basically what Calvin bought cost twice as much. So 2 of what Susie bought is equal to what Calvin bought. So I just did 2 times 4M plus 3B. So 4 muffins plus 3 bananas equals 2 muffins plus
Sorry, I had to
2
sneeze,
bananas.
and I was surprised at the beginning. Okay, can you write that?
Yeah.
Okay. You lost me after the first thing where you said you were going to double what Susie bought instead of equal to what Calvin bought, I guess.
Yeah.
Okay. But then I was sneezing, and I don't know what you said after that. And you were talking really fast. Okay, good.
Okay, so I put 2 times 4M plus 3B equals 2.
What Calvin bought.
Yeah. So this here is Susie and this is Calvin. So Susie, like they said that Calvin's was twice as much as Susie's, so that means 2 of Susie's would have to be equal to Calvin's. So I just solved that out and I got that 6M equals 10B. So you get that 1 banana equals 5/3 of a muffin.
And this is where it circles back to Math Madness, I think. How often they ask us the ratio or something to something. When they said a muffin is how many times as expensive as a banana, they wanted muffin to banana cost. Did y'all understand what Grace was saying? Any other reflection on what she was saying? I did something similar that I don't like as much, and I knew I didn't like it when I was doing it. Every now and then, I take off my math team coach hat, and I just can't help myself, and I turn into an algebra teacher, and I set up a system of equations. I'm not real happy that I did that. I got the answer right, but I knew that I didn't like what I did. I'll always be honest with y'all. I think we can all learn. That just makes such logic, and that's what we're looking for. She's got about twice as much to equal what Calvin got, and then she's just looking for her ratio. Okay, that was great. So a bunch of people got it. Other comments on the 5/3, 5 to 30? You might have made up money or amount of muffins or bananas. Did everybody do it similarly that got that?
Yeah, I did.
Okay. All right, so I bet some people have worked number 6. Number 6 is very doable if you're following order of operation. Anybody want to give us the answer to 6? Well, the answer is C a lot of times, okay? I don't know that I need to go over that. You add up your fractions with a common denominator. Now, this is out of AMC, and I'll double check, but I think this year you can use your calculator. You could just carefully type that into your calculator and get it right. But, anyway, do y'all feel okay on that one? Because what does a -1 make you do to your fraction? Flip it in, okay? All right, and there's gonna be some, kind of like last year, those of you that took the AMC, there's going to be some questions that are going to be what I call gimme questions. There's probably the ones you got right a lot of times last year, and we want to work on the others too and add those to the list where you're not intimidated. A lot of these problems that we're looking at today, if you took the AMC last year, you probably think, oh yeah, this is the kind of things that I saw, but I don't know how to do this. So now, let me give you a second to look at number 7 while I draw it. And just out of curiosity, does anybody already have the answer to number 7? Okay. I should not try to draw this. I should pull it up. But. Just so you know, this is the world's worst hexagonal drawing. I have no idea how I'm going to even make this work. Hang on. It's like me trying to lay a tile floor and it doesn't work at the end. Ah, this is horrible. Sorry. The answer is not C this time. At some point, I'll find the old handout that we use for our Memphis math team. It has a whole lot of this stuff on it. You might get B. Got 3 B's. All right, the answer is B. You may still be working on it, which is fine. It would be totally believable that you'd still be battling around with this right now. All of the thinking that you're doing and processing helps so much. Even if you felt like you're like, oh, you look up at what somebody else did, like I do quite often, and go, oh, well, I can just double what she bought to get Calvin's muffins. I compare it a lot to if, you're trying to teach me to do something, play the piano, shoot basketball, sing a song, or whatever. You got to kind of watch me do it, or I've got to at least try, so that you can tell me where a better way to do it. You're like, oh, you should maybe, what did I use? Basketball, sing a song, whatever. Y'all know what I mean. You can really give valued instruction after somebody's tried something. All right, Libby, you want to tell us what you did? Can you explain it? Sometimes I can't explain what I did.
Well, I just tried to find like the length of like the sides first of like the triangle, and then I worked towards like the base, like the height of it. So I took like one of the parts of how like it overlaps with one of the hexagons, and then I was it a 30, 60, 90 triangle?
We're back at 30, 60, 90.
Yeah. So then
Okay.
I just kind of like used the ratios for that, and then I found that the side length, so like the whole triangle, was 4√3.
All right, so let me slow down. I think, and Libby can correct me if I'm wrong, but we're going to zero in on one of these little triangles right here. Is that kind of what you did or no?
Yeah.
Okay. So then, since it's a regular hexagon, that creates, the regular hexagon, I think you needed to know this. I needed to know that was 120 degrees. Okay? How did y'all know that was 120? Do y'all know the formula n minus 2 times 180? Or, I don't know, talk to me about that.
Yeah.
Okay, so to find the sum of the interior angles, like of a triangle, you have 3 sides. So, of course, it's 180 degrees. And if it's a regular one, you would divide it by 3. And y'all know that each one would be 60, which is going to be something I need to bring up before we go. So I said 180. They had 6 sides. And that would give me the sum of the interior angles, but I wanted each one. And I believe that's what I did to get 120. Some of you just know that it's 120. I mean, that's okay too. That created for Libby this 30, 60, 90 again, which is very, very common. And so right in here, she had a 30, 60, 90. Then what? Oh, you knew these were 1.
Yeah, it said the side lengths were 1 for the hexagon, so then I just
And this was the hypotenuse.
So it would be the short side would be 1/2, and then the other side would be √3.
Right, this side would be 1/2, and this side would be √3.
So then I took the √3 and I multiplied it by 4 to find the side
Wait,
length.
I've done something. This would actually be √3/2. If this is 1, this is 1/2, and so this would be √3/2, but I think what you're talking about is you went ahead and added those together. This whole thing is √3. Like if I have this 30, 60, 90 triangle, and this is 1, this is 1/2, and this is √3/2. Okay, and then did you add them together and get √3 for the whole thing?
Yeah, I just tried to find like the whole,
Okay.
like the bigger triangle, like the side lengths, so I could use that for like the base times height to find the area of it.
Okay. Oh, well, what I mean is when you said this side would be root 3, I just didn't know what you were talking about there, because that would be root 3 over 2. But I'm assuming you did it right, because you got the right numbers. Okay. So let's pause for a minute. Does everybody see what Libby's talking about without me interrupting her? So 1 whole side is how long? 2 root 3. All right, so this whole side right here, this green side, is 2 root 3. Now, I'm going to pause, Libby, and not let you finish, okay? The reason I'm not going to let you finish is I'm going to give you something that you can use in AP Calculus, on ACTs, on SATs, and on math exams. It's just something that you should know, okay? If equilateral triangle, the area, oh, well, true, that too, Grace. If it's an equilateral triangle, it's always square root of 3 over 4 side squared. You don't have to struggle with the altitude. It's always square root of 3 over 4 side squared, and Libby knows we've got an equilateral triangle, right? So Libby, if we'd gone square root of 3 over 4 side squared, that gives me square root of 3 over 4 times 4 times 3. And so I get 3 root 3 for the area of the triangle. So that's a little easier than having to struggle back, but not a whole lot, but a little easier than having to struggle back with the altitude. Because then you're back at 36 and 90.
You've done it and you found the altitude?
Yes.
I found the altitude of the center next to me. And then
Oh, I don't know. Did you finish it? Finish it and let us
I didn't
know.
realize that I got the right answer when I did it, and I didn't know what to do with it, but I got through 3.
Okay, so I think we kind of need to go to make it to class. But girls, either I can keep these or bring them with you when you come, because I want to talk about. Do y'all want me to keep them?
Yes.
Okay. And then Monday, try to be here. If you're not here Monday, I will report it. Okay?
What time should we be here?
Yeah. I think it's 2:10. So, and we're going to talk. It's 2:10. Did you get 2:10? So I'm going to want to know how you did that. So I kind of did it a long way too. Somebody else have a question? What time should we be here on Monday? I would say, I think that's a long lunch too. Yeah, I would say 12:45. Is that enough time? Yes. Thanks, girls. Great job. Good practice.